last night, the p-value test. So the first question said, how about everybody mute your mic until you have a question? That way there won't be so much background noise. Yeah, just mute your mic unless you have a question, and then we'll, yes, somebody just drew on my board, okay. Mute your mic and, all right. So first question said, 2 Polish math professors and their students spun a Belgian euro coin 250 times. It landed on heads 140 times. Excuse me, my wife's cooking and it's gonna make me cough a bit. One of the professors concluded that the coin was minted asymmetrically. A representative from the Belgian Mint said the result was just by chance. Is the math professor or the representative from Belgian Mint correct? At the 0.01 significance level, test the math professor's claim that the coin is not fair. So first thing, what's our claim? Our claim is that the coin is not fair. So that's the first thing I want to look at. That's going to tell me my hypothesis, my hypotheses. So write down your null and your alternative. All right, the coin is not fair. What does that mean? Can anybody tell me? No.
Our mics are muted, Mr. Wallace.
Yes, your mic's muted. So if you know, unmute your mic and give me a. I have no idea what that means. 50-50. Okay, Jordan says 50-50. 50-50 would be fair. What would be unfair?
40-60.
40-60 would be fair. Anything greater than 50-50, right? So, yes, not 50-50 would be unfair. So, a value greater than 50 would be unfair. And it's 50%, so 0.5. We know that's the alternative because it doesn't have the equality in it. It's greater than, not greater than or equal to. If it was equal to 0.5, then it would be fair. So we don't want the equality on there. So that's where our claim is. Our claim is in the alternative. That makes our null less than or equal to 0.5. All right, we got the first part down. That's our hypotheses. Now we need to write our info down. Spin. How many times we spin the coin? 250. P hat. Well, that's the proportion of success. So we got heads 140 out of 250 times. So 140 out of 250. So TI users, you're going to use that 140 in your calculator for X. Non-TI users, don't worry about it. Sure, Trevor, eat it. What else do we need? We need alpha. It tells us the significance level is 0.01. That's our alpha. Yes, my wife's trying to kill me with her cooking. And I think she burnt it. So, so that's P hat, N, and alpha. It's not, that's not very nice. No, she's put way too much pepper and it's burning, so it's killing us. And she burned her chicken too. And she's laughing about it. Anyway, we also need P. That's 0.5. We always use this value right here for P. Even though it's greater than 0.5, we use 0.5 as the P. That makes Q 1 minus 0.5, which is also 0.5. Now we have everything we need. Let's grab our formula sheet and look at our formula. On the back of the first page, top left, right there. That's how we get the test statistic. So after we write down our info and our hypotheses, the next thing we need is our test statistic, regardless of which method we're using. I'm gonna do these both ways, by the way, even though the homework just said p-value. So now we're actually gonna start doing some math. We're gonna figure out what the test statistic is. To do that, we do p hat minus p over the square root of p, not p hat, times q, all over n. N was 250. I'm going to pause right there. Does anyone have any questions? Here, we got a chat here. Not. Jordan says not. Okay, then I'm going to take the Casio, because TI uses, you're just going to type it in and be done. But Casio uses, you're actually going to need to get that test statistic. So I got a fraction and a fraction. Somebody's mic is not muted, and they're kind of singing in the background.
I think it's Heidi.
I turned it. Wait, I'm sorry.
Taylor says 1.9. Okay. Well, I just type it in to be true. What is what?
Nothing. Never mind.
Okay. So I'm just typing this in. Oops, I need a fraction. And the reason I'm going to type it in anyway, even though Taylor told us it was 1.9, is because I actually want to save this number, and 1.9 isn't good enough. We'd actually write 1.90. We need at least 2 decimal places. If we're using the critical value method, the traditional method, we need 4 decimal places. Yeah, still not muted. Okay. So I'm going to take this value and save it, store it to one of these letters. So shift, recall right here, and then A. That way later on, whenever I get the, whenever I find the p-value, I already have that exact answer in there. It'll be easier for us. So 1.8974. Okay, let's see what the chat said. Oh, I'll look at that. Oh, excuse me.
Yeah, Heidi, you're making too much noise.
I'm not. That's not even me. There's nothing in here making noise.
Heidi, you should mute your mic, says Jordan. She's muted now. Don't unmute yourself. Okay. So that's the test statistic. So now we can jump straight to the p-value method if we want to. I'll do both ways. So we look at our tail. What kind of tail do we have? We have a right tail because the alternative is greater. We always look at our alternative for our tail. So that means we need to look at the area to the right of our test statistic. If you don't remember, there's a flow chart back here somewhere. Right here. So at the right tail, we look at the area to the right of the test statistic, and that's our p-value. So to get the area to the right, we could use this chart. I'll do that first. It was 1.90. I would round to 1.90. So I'm going to look up 1.90 on the chart. 1.90 is 0.9713. I'm going to write that down. 0.9713. However, we want the area to the right. If you remember, this chart gives us the area to the left. To get the area to the right, we're going to have to do 1 minus that number. So it's going to be 0.0287. So the p-value test tells us if p is less than alpha, we reject the null. Let's see what we have here. P is greater than alpha. So we're going to fail to reject the null. So that's what that tells us. Now from here, we could write our final conclusion, but I'm going to go ahead and show you the traditional method as well, just in case you prefer that method. To the traditional method, we need the critical value, or value in this case. Since we have a right tail, we just use alpha. We find the critical value corresponding to 0.01. It's a 1 tail, we don't cut it in half. So using the chart, 0.01. Okay, right here is the closest one I'm gonna get. 2.33. So the critical value, I'll do it back, is 2.33. It's a right tail, so we just have one critical value, and it's the positive one. So get your curve. 0 is going to be in the middle. Critical value, 2.33. Shade it. Now we're going to plot our test statistic. Let's see. 1.90. Well, that's between 0 and 2.33. So I'll put it right there. The test statistic is not inside the rejection region. Since it's not inside our shaded region, we fail to reject the null. So both of these methods give us the same result. Okay, now I'll do it on the calculator, Casio first. To get the p-value, remember I stored this number to A. We need the area to the right of that. So all I'm going to do is go to my normal CDF. My lower bound will be A. My upper bound will be infinity. And don't mess with those. 0.028. Same thing we got here. So that would get you the p-value on the Casio. To get the critical value on the Casio, we do an inverse norm. We do an inverse norm of our alpha value. And that gives us the 2.33. Again, it's a right tail, so we use the positive. TI users, you're in luck. Just type in the stuff and you're done. So we're going to go to stat, test, number 5. T was 0.5. X, remember, is this numerator here. If we don't have this numerator and we have a percentage, we'd multiply it times n and round. N was 250. And we had a right tail test. Calculate that. And it gives us our test statistic and our p-value instantly. Test statistic and p-value. So with that, you would be done. Just use a p-test and you have that you fail to reject the null. Since we fail to reject the null and our claim is in the alternative, there is not enough evidence to support the claim that the coin is not fair. So that comes straight from this chart right here. This chart must be known to you. If you don't know this chart, learn it. So we failed to reject the null and the claim was in the alternative. there is not enough evidence to support the claim, then write down what the claim is. So that was the entirety of this hypothesis test. Pausing for questions. Any questions? Speak now or forever hold your peace.
When you said to calculate it on the TI, you go to stat test number 5, and then after you get something, you said multiply it times n and then round.
Okay, if, let's say, instead of T as 140 over 250, let's say we had that as a, whatever percentage that was over 250. So let's say they gave us 0.56 for percentage. So what you do is you take the 0.56, whatever your percentage was for P hat, and multiply that times your n value. And then if that was a decimal, you'd have to round it.
Oh, okay.
Okay. And then from there, we get our Z and our P values. Wait. Okay, Jordan, wait. I'm waiting. Where did you get 0.9713 from? Okay, I got that from the chart. If we do it by hand, we look up our alpha value on the chart. So our alpha value is 0.01. 0.01, so we need to find where that is on the chart. And the closest, oh, sorry. We, this 0.973, we looked up the test statistic, so 1.90. So we go 1.90 right here. That gives us 0.9713. That's the area to the left of the test statistic, because this chart always gives us the area to the left. We, however, need the area to the right. So to get the area to the right, we do 1 minus that value. However, Jordan, you have a TI, so you don't have to worry about that. It spits out the p-value for you. And Casio users, you can just type it in normal CDF. So if you don't have a Casio and you don't have a TI, you can still do it with this chart. Or if for some reason you like the chart on your head, like Trevor, then you can do it that way. You probably want to be able to read it instead of putting it on your head. Further questions? Okay. Would you mind telling me how to get the thing on the TI again? 25th time's the charm, right? So grab your TI. Let's pretend you're at the home screen. Stat. Go to test. Now we're doing a proportion test. So we're doing a 1 proportion Z test, number 5. Type the information in. T is 0.5. It says T0. Yes. Thank you. Quite well.
Mr. Swallow.
Yes.
I have that formula sheet thing, but is the chart that we're supposed to use on there?
Yes, it is. This is
Which
the actual form. This is the formula sheet right here. So
which
here's the
chart is it? There's like 6 charts.
yes. Well, we're using the normal approximation to the binomial distribution for the proportion. So we use the Z values for the proportions.
So
We use the G sign.
what?
Z. We're using Z.
Okay. Thank you.
Next week, welcome. Next week, we're going to have to use both Z and T. We're never going to use the chi-square one because we just don't do variance in this class. Your screen isn't changing. Oh, interesting. Can you explain the critical value again? Okay, so apparently you don't see whenever I switch tabs. So yeah, make sure you have your chart in front of you so you can follow along what I'm doing. the TI. Do you see the TI? Does anyone see the TI in front of you?
No.
No.
No. Got it. Okay, let's see. Pause share, new share. Let's try that. How about now?
Yeah, I see it now.
Okay. So let's get out of here. So we're gonna go to stat, test, number 5. Type the stuff in. T is 0.5, X is 140, N is 250. Here's a right tail test. We hit calculate, and it immediately gives us our test statistic and our p-value. Okay. So if
Can you
we
do
were
that on? Can you
Not
do that
quite.
on the calculator?
on the Casio,
Yeah.
no, you cannot.
No, but like, can you show us how? Because I still, every time you do it on like your videos, you just like zoom through it.
Okay. So we need to get, and I didn't forget your question, Claudia, critical values. We're going to do all that again. So first you need to do is test, calculate the test statistic. So you go to mode 1 and just type all that good stuff in. So to calculate the test statistic, we use the formula sheet. The first formula, the top left corner on the back of the first page. And it is as follows: T hat over N, well, P hat, that's X over N, minus 0.5 over the square root 0.5 times 0.5 over 250. So this is the test statistic I just typed in. That's the 1.89, the test statistic. What I'm going to do with that is save it. I'm going to store it. Shift RCL, and then pick a letter. Doesn't matter what letter. I use A because, well, why not? That gives the test statistic. After you have that, make sure you write it down. You can either do the p-value method or the critical value method. To the p-value method, we're going to get the area to the right of this because it's a right tail test. Mode down, number 3, normal CDF. The lower bound would be our test statistic, so it's A. I'm just going to put in A there. Our upper bound is infinity, 1 times 10 to the 99. And leave these guys alone. That gives us our p-value, 0.0289. That's the same thing we got using the chart. You know, it's going to be slightly different based on rounding, but whichever way you do it, it'll be fine. I'll take all the different possible answers. That's how you get the p-value. So Heidi, after we have the p-value, all we have to do is compare it to alpha. So let me go back and share this one. So we calculated the p-value right here, right here, Heidi. We compare that to alpha. P is greater than alpha. That means we fail to reject the null.
Oh.
That means, so the calculator, the Casio, just gave us the p-value, and we compare that to the alpha value. If P is bigger, fail to reject the null. If P is smaller, reject the null.
Thank you.
Welcome. Okay, Claudia's question about critical values. So she wants to know how to get these guys. So you have 2 choices. You can either use an inverse norm or you can use the chart. I'll show the inverse norm first. So we're going to do mode down here, distribution, inverse norm. Area, that is alpha. If it's a 2-tail test, you have to cut that in half. Okay, 0.01. It is a 1-tail test. We do not cut it in half. Leave these alone. And we get 2.33. The positive or negative depends on what kind of tail you have. If it's a right tail test like we have here, we take the positive. The 2.33 is our critical value. Now, if you wanted to use the chart, we're going to use this Z chart, and we look up 0.01 inside the area. So we get whatever's closest to that. It's coming around here somewhere. Oh, here we go. So 0.0099 is the closest thing we're going to get to 0.01. So I look at the chart, it's going to be 2.33. So you have to add the left and right, the left column and the top row to get that total Z critical value. So that's how you can do it on the chart. Inverse norm on the calculator. Okay. Any more questions on this one? All right. Oh. No. Okay. All right. Let's go to the next one. Any basketball fan knows that Shaq was one of NBA's most dominant centers, and he sucked at shooting free throws. Over the course of his career, he made 53.3% of his free throws. One offseason, Shaq had been working with an assistant coach on his free throw technique. During the next season, a simple random sample showed Rip Kobe. Yes, helicopters. Simple random sample showed that Shaq made 26 of 39 free throw attempts. Testa claimed that at the 0.05 significance level, Shaq significantly improved his free throw shooting. So there's my claim. Well, that's alpha. Has improved his free throw shooting. So improved would mean it's bigger than it was before. So that's going to be greater. So my null, my alternative. If I'm talking about greater, that's going to my alternative. 0.533. So that's my alternative hypothesis, and that's where the claim is. The majority of the time, your claim is in the alternative, because that's the only way we can actually prove something is true. Less than or equal to 0.533 would be the null hypothesis. So now, write down our information. He made 39 to 26. So 39 for N. T hat is going to be that 26 out of the 39. And the claim is at the 0.05% significance level. That's alpha. We have P over here, 0.533. Do 1 minus that to get Q. 467. We have all the information. We have our hypothesis test, and we know where the claim is. Now we're ready to start doing some work. So, gonna use that test statistic again. So there's the formula. It's on the back of the formula sheet, top left, if you don't remember. That's where all your test statistics are. So next week, whenever we deal with the mean, we'll also have our 2 test statistics for the mean there. Plug in the numbers and figure out what the test statistic is. T hat. T. Square root of P times Q. Over N. N was 39. Okay, and we need to type that in the calculator and see what we get. I'll pull up the Casio. So go back to mode 1, and we're going to type this in. I need a fraction of a fraction. 26 over 39 minus 0.533 over the square root, fraction again, 0.533 times 0.467 over 39. So I just typed exactly what we wrote down for the test statistic in the calculator, and I hit equal. 1.67. All right. Store that for later, or you can just write it down. Doesn't really matter to me. I'm lazy, so I store it to a letter, so I just have to type that letter later. 1.6731. I'm gonna go ahead and write that down. So TI users, I'm going to do the TI after we finish. I'm going to go all the way through with the Casio first. So now that we have this test statistic, we need the p-value. So we can do that using the formula sheet or the Casio. Sorry, I have the Casio up. Let me just do it on here real quick. Cancel that. So to get the p-value from the Casio, we look at our alternative. It's greater than again, so we need everything greater than this. Mode, distribution, null CDF. A is my lower bound. Infinity is my upper bound. Leave those alone. We get 0.047 for my p-value. So I'm going to write that down.
You said normal CDF, right?
Yes, it's a normal CDF. We need the p-value. The p-value for a right tail test is the area to the right of the test statistic. So we get the lower bound as our test statistic. Upper bound would be infinity. Mean and standard deviation are 0 and 1, like always. So now that we have our p-value, we can write our first conclusion. T in this case is less than alpha, barely, but it's still less than alpha. So that means we reject the null. Anytime T is less than alpha, we reject the null. Okay. So now we're done with that. If we want to use the traditional method, get the critical values, we can. Don't have to, unless, you know, the problem actually says find the critical values and sketch it, then you would. So to get the critical values, we'd use the inverse norm of our alpha. So grab the Casio again. So I'm going to go to inverse norm and type in alpha. So I get 1.645. So my critical value is 1.645. So I'm gonna sketch that. Oops, can't see this, can you? So my critical value is 1.645. Make your sketch. Mean is 0, always in the middle. Then you plot your critical value. I'll put it right here. 1.645. It's a right tail, so we're shading to the right. Now I plot my test statistic. Put it in blue. 1.67. Well, that is in here. It's in the rejection region. So that means we reject the null. If our test statistic is in the shaded region, we reject the null. Okay. TI users. I'm going to take care of you now. Okay. So I'm going to go to stat, test, number 5. P was 0.533. X, that's the numerator of our P hat, 26. N was 39. And it was, again, a right tail test, calculated. Oops, I typed something in wrong. Oh, I didn't put a point. That might help. There we go. 1.67 for my critical value, 0.0471 for my p-value. Oh, hey, look at that p-hat. Let's see, who is that? Audrey, muted. All right. So now that we have both ways the p-value, we can write our conclusion. We rejected the null. The claim was in the alternative. That means there's enough evidence to support the claim. There is enough evidence to support the claim that Shaq has significantly improved his free throw shooting. So that would be our conclusion based on this hypothesis test. Okay. All right. Any questions on that one? I'll take this time while I'm waiting for questions to show you how to find the critical values on the TI calculator, just in case you don't remember. To get to inverse norm on the TI, you go to second bars, number 3 for inverse norm. Type in your area, and it'll look something like that. And we get the 1.645. Okay, seems like no questions, so moving on to the next. Let's see. Different from 8%. Okay, we got a two-tail here. So let's look at it. According to official census figures, got a couple questions. We reject the null because what? Okay, never mind. 2 ways we reject the null. If P is less than alpha, we reject the null. If our test statistic is in the critical region, the rejection region here, the shaded part, we reject the null. If P is greater than alpha, or it's not inside the rejection region, we fail to reject the null. So these are the 2 ways we know to reject the null. Okay, so I can always look at alpha. If we use a p-value test, yes, we compare P to alpha. So first find P, and then you can compare that to alpha. Okay. 8% of couples living together are not married. A researcher took a random sample of 400 couples and found that 9.5% of them are not married. Tested the 5% significance level if the current percentage of unmarried couples is different from 8%. So I always like to write down my hypotheses first. Test the current percentage of unmarried couples is different from 8%. While different would be what symbol? Somebody tell me.
Not equal to?
Correct. And not equal to would be in the null or the alternative. where does null go? Where does not equal to go? In the null or the alternative?
The null.
Not equal goes in the null. Not equal goes in the null. Actually, not equal goes in the alternative. Remember, the null always has equality in it. So if it's equal to, greater than or equal to, or less than or equal to, that's what goes in the null. If it's not equal to, less than, or greater than, that goes in the alternative. So anything that does not have equality in it goes in the alternative. And this is again where our claim is. Okay. So now that we have our hypotheses and know where our claim is, let's write down our information. N was 400. And P hat, all right, so this is a good example for TI users, is 9.5%. So I'm going to put 0.095. Test at the 5% significance level. So alpha is 0.05, 5%. And P was 0.08. That makes Q 1 minus 0.08, which is 0.92. Okay. Again, we're going to use our test statistics. So if you don't have it memorized already, there it is. It's also on the formula sheet. P hat was 0.095. P was 0.08. Square root. P was 0.08. That's what we're looking at. Q was 0.92. All right, N was 400. So we got that. That's our test statistic. Type it in the calculator and see what we come up with. All right, mode 1, a fraction, 0.095 minus 0.08 over the square root of a fraction, 0.08 minus times 0.92 over 400 and 1.1. So that's our test statistic. So that's our test statistic. I'm going to write it down. 1.058. Now, it's a two-tailed test, two tails. So that means we're going to have two critical values if we do the traditional method. And if we do the p-value method, we're going to have to find, we're still going to have to draw it. So we're going to go ahead and draw it in a minute and see whether or not it's the left or the right. Yes. Why isn't it 1.11? Because I rounded to 4 decimal places. How do we know it's a two-tail? To determine your tails, we look at the, what do we always look at to determine what kind of tail we have? Anybody?
Alpha.
Okay, no, not alpha. Alpha will give us our critical values. Okay, we got a couple. High. Oh, H1. Yeah, I think Joe meant H1. So yes, we always look at our alternative. This alternative tells us our tails. Yes, he said. Okay. Always look at your alternative. It's a not equal to, that makes it a two-tail test. A greater than is a right tail test. A less than is a left tail test. So right now we have not equal to. That means it's two tails. So I'm going to go ahead and sketch it. Notice I haven't found the critical values yet. Even if we're doing the p-value method, we're still going to sketch this. So I'm just going to go ahead and, because it could be either greater or lesser. Sure, yes, that's why we call it a two-tail. So we need to find out where this test statistic goes, if it's to the left or the right of the mean. Well, it's positive, so it's going to the right. So here's my test statistic right here. And it's to the right of the mean. So that means we need to find the area to the right of the test statistic and double it. So let me pull up, I think it's on this formula sheet. So finding p-values, here it is, right there on your formula sheet. We have a two-tail test. The test statistic is to the right of the center. We find twice the area to the right of the test statistic. We're going to find the area to the right and double it. So we could go ahead and use the chart since we're here. Do it by hand for people that like to do that. It was 1.11 if we rounded two decimal places, which is what we need to do for using the chart. Positive 1.11. So 1.11 would be 0.8665. Let me write that down. Question? That's why I asked why it wasn't one. Because Jobert, if we're doing the traditional method, we need 4 decimal places. If we're doing the p-value method, we round to 2 decimal places. So I write down 4 decimal places, and that way, either way we do it, we're good to go because we can round again to 2 decimal places later. All right. So, oh wait, you probably are still on the screen, aren't you? So this is the area to the left of the, okay, Lakin, I suggest earphones. Those are very useful. Shoot, I lost it. 1.11. This is the area to the left of our test statistic. We need the area to the right. So what I'm going to do is 1 minus that area. And that'll give me 1 minus 0.8665 would be 0.1335. So that's our p-value. No, it's not. It was a 2-tail test. After we find the area to the right, we must double it. So multiply this by 2. So times 2 on the calculator. That'll give us 0.267. So using the p-value method, we can already say, oh yeah, we have p is greater than alpha. We fail to reject the null. So let me go ahead and walk through all the steps on the Casio.
Mr. Swallow.
Yes.
if we take that number thing that you said a while ago and compare it to A, do we have to do that hill looking thing?
Okay,
Graph,
so
whatever.
there's the p-value method and there's the traditional method. You only need to do one of them, but the question might specify which one you need to do. So you need to know both ways.
Okay.
On some of the questions, does it let you choose which one to do?
I'm sorry, what was that?
I said on some of the questions, does it let you choose which one you want to do?
Yes.
Or does it always say?
Well, the only way I can force you to use one way or the other is if I specifically ask for the p-value, or let's say have you match which curve sketch matches that situation for the critical values. Otherwise, it's just a hypothesis test. You could do it either way, and I wouldn't know. Because again, I'm not looking at your work, so don't type a bunch of work in there and not answer but one question. Also, paper and pencil is useful for your quiz. Try it next time. All right, so where were we? Oh yeah, Casio. So to get the p-value on the Casio for a two-tailed test, we're gonna, I hope I typed, did I save my test statistics? I don't think I did. Oh, I did, good. So we already have our test statistic. We need the area to the right, since it's to the right of our center. Normal CDF, lower bound would be our A, our test statistic. Upper bound is infinity. Leave those alone. We get that number. Again, that number is not our p-value because we had a two-tailed test. That's this number we got right here. So we're gonna go back to mode 1, type answer, and double it. That's our p-value, 0.2688 if we use the calculator. Slightly different from the chart, as it will be since the chart rounds 4 decimal places every time. But either way, we reject the null, fail to reject the null hypothesis. TI user's turn. So let me do this and this. There we go. So T is 0.08. That's the first thing I need. That test number 5.08. X. This time we aren't given a specific X value, so we have to calculate it. 9.5% of 400. And oh, good, it's a nice integer number, 38. If it wasn't, we would have to round it. Otherwise, we get a domain error. And this time it's a two-tailed test. Make sure you check that. And I have a question. I did not say, hey, Siri. Wait, so traditionally or the p-value method are both done the same way on the TI? Yes, on the TI, we do it both ways because we need the test statistics. That gives us our test statistics. After that, you get your critical values using inverse norm. If we're doing it traditionally. So hit enter and we get the p-value is 0.2688. It also gives us our test statistic right here. So either way, if we're using traditional or p-value method, we need this test statistic so that TI can give it to you like that. If you're doing the traditional methods, you're still going to need to do the inverse norm. So let's do that now. Second bars, inverse norm. Anytime we have a two-tailed test, we have to cut alpha in half. So instead of 0.05, we're going to do, instead of 0.05, we're going to do 0.025. And that'll give us a negative, well, 1.96 plus or minus. So I'll sketch that. Let me put you back on the screen. Okay, so there's the mean. Our critical value was 1.96. I'll put that over here. It was also negative 1.96 because we have a two-tailed test. So we have two different critical regions, the left tail and the right tail here, because it's a two-tailed test. Plot our test statistic, 1.11. That's right here outside of the rejection region. So again, we're going to fail to reject the null. We get our critical values using inverse norm or the chart, your choice. For a two-tail, chop alpha in half. Okay, now we're going to write the final conclusion. Let's see, our claim was in the alternative. So we had our claim in the alternative. We failed to reject the null, so there is not enough evidence to support the claim that, how do you know where the claim is? You read. The current percentage of unmarried couples is different from 8%. Different is not equal to. Not equal to is the alternative. Remember, the alternative always has the part that does not include equality. The null has the equality. Bet. There's not enough evidence for the claim that the current percentage of unmarried couples is different from 8%. So that's why I like to write my hypotheses first. Someone do something crazy on camera, really. Let's see, I don't even see everybody's cameras. I see, oh, there's Trevor's and Heidi's. I think Trevor's hailing Hitler there. Anyway, any questions on that one? Seems like a no. Okay, let's see. We got two more questions here. More than, I think, right tail. Majority. I made all these right tails. So make some left tails in there. Let's go ahead and do this one first. Well, next. In a survey of 2,450 adults, 52% said it is not morally wrong to change the genetic makeup of human cells. At the 5% significance level, tests the claim that the majority of adults do not think it is morally wrong to change the genetic makeup of cells. So first and foremost, Joe Bear, you're up. What's my hypotheses? We got 2,000 new corona cases in Louisiana today. Yippee. Joe Bear. Hey, I'm trying to mute you here. You're on the air. Joe Bear. Scaredy cat. All right, can somebody help Joe Bear out? What are our hypotheses? Mommy, can you range her stuffed animals for her?
Yeah, it's 0.05.
What is 0.05? What do you mean by it is 0.05? Hypotheses are very specific.
I don't know if it's greater than or equal to. I think it's greater than.
Okay, so majority, that indicates yes, greater than.
Yeah.
Where does that go?
P doesn't equal is like equals P greater than is greater than 0.05 and high H1.
H1, yes. So Jordan, yes, you're correct. It's greater than 50%. So that goes in the alternative.
Then ho is the opposite of that.
Yeah. So our null is less than or equal to 0.5, our alternative is greater than 0.5, and that is where the claim is. My daughter doesn't want to take a nap. In a survey of, okay, so let's write down our information now. In 2,450. So if you can't write down your hypotheses, you are literally screwed for this entire chapter. So make sure you're able to read this and write down if it's, P is greater than 0.5, less than 0.5, not equal to 0.5, whatever it may be, and where it goes in the null or the alternative. If you can't do that, you will literally get every single question wrong. So make sure you can do that. P hat in this case is 52%. Alpha is 0.05. P was 0.5, which makes Q also 0.5. So does everyone understand how to read the problem and get the information from it? Question C. Yes. How about a die in there? Any dials? Da. Okay. So yeah, read the problem, write down the information, make percentages decimals, and you're good to go. Same formula we've been using. Let me change color. I like that, Lakin. P hat minus P over square root P times Q over N. Wait, what? Were you paying attention, Lakin? Shame on you, not paying attention. Anyway, that's our test statistic. Let's shove it in the calculator and see what it spits out. I talk fast. Hey, how does this work? So what do you see right now? Do you see the screen and the calculator and your faces?
Yes.
Okay, that's what I want. Why? I don't even know what you're trying to say, Audrey. So type this in. Yeah. Anyway, we got a fraction going on, 0.52 minus 0.5. Square root the denominator there with a fraction. I'm going to save some time. 0.5 times 0.5 is 0.25. I just didn't feel like typing it. So my test statistic is 1.9799. Again, 4 decimal places here because that'll help us out for the traditional method. P-value method, we only need 2, but we're actually going to save this entire thing. So we have about 30 decimal places here right now. Casio says 30-ish. TI says about 52. So neither one of them are exact answers, but they're close. That's my Casio's test statistic. From there, I'm going to get the p-value. So I need to look. The right tail test. I need the area to the right of this. So inverse null CDF. A, infinity, leave those alone, and see there, it is A. That's the test statistic right there. 0.0239. P is 0.0239. And we compare that to alpha. P is less than alpha, we reject the null. Okay. TI users. So let's see, can you see my TI now?
Yes.
Awesome. So that's the screen I want to share. Okay. So TI users, we're going to type all this information in, stat, test, number 5, 0.5 for P, and 52, hope this is a nice integer, if not, we'll have to round it, 0.52 times 2450. Oh, good. Turned out to be a nice number. N was 2450. And we have a right tail test. So now we have the test statistic and we have the p-value. So as you can see, the TI users did a lot of time savers right there. And they could pretty much just be done, use a p-value test and say, oh, reject the null. Claims in the alternative, so we support the claim. But let's go ahead and do the traditional method as well. So we don't need the p-value for the traditional method. We do need the critical values though. Right tail test, so we don't cut it off in half. We're going to go to inverse norm and type in our alpha value. It goes alone, 1.645. So that's my critical value. I'm using positive because it's a right tail. My critical region is to the right of that. Now I'm going to plot my test statistic, 1.98. That's in that rejection region there. So again, we reject the null. TI users, to get your critical value, second bars, inverse norm, number 3. And what you're going to have is something that looks like this. Inverse norm 0.05. You could actually leave these off and it won't make a difference. So if I just do it 0.05, it'll still give you the same critical value because it'll assume that it's a standard normal distribution. So 1.645, that's my critical value. Plot your test statistic, and then you have that we're rejecting the null. So the claim was in the alternative, so there is enough evidence to support the claim that, let me highlight the claim so I can read it. The claim that the majority of adults do not think it is wrong to blah, 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 blah. The majority of adults do not think it is morally wrong to change the genetic makeup of human cells. Questions on that one? Okay, 3 popped up. Wow. I like your profile pic, Audrey. Thank you. 1.9799. Why? Speaking of slavery, I'm making a villager breeder in Minecraft right now. Yeah, sure. Anyway, questions on the statistics problem here. Questions on traditional testing or, okay, you got a question maybe? Yes. What's your question? They don't get how you see where the claim is. Okay. We read. The majority of adults do not think it is morally wrong to change the makeup of human cells. Majority tells us greater than, not greater than or equal to, just greater than. That's the alternative. That's the claim. You told me it was greater than. So null will have equal to, greater than or equal to, or less than or equal to. That's the null. If your statement is one of those, it's in the null. The alternative will have not equal to, greater than, or less than. If it's any one of those, it's in the alternative. So you read what your statement says. In the TI, whenever I type in second bars, where the, no, you're just putting in your alpha value for inverse norm. Okay, how does it make it alternative? Write it, draw it down. Majority. So majority is greater than 0.5. Do you see that? Waiting for a response. Still waiting. Hello?
Wait, so the where are you getting 0.5 from?
Majority. What does majority mean?
Greater than.
Majority means more than half.
Oh, okay.
So if I say the majority of statistics students in our class are male, that would mean more than half are male. It could be all of them male, but more than half of them have to be male.
So does that 0.5 still have the same thing to do with P and Q? Like, is that the same 0.5 that you're referring to?
Yes, our p-value, this is the population, the parameter here, 0.5.
Perfect.
P hat is what we have from our sample. So what it tells us, majority, that means greater than half, more than half, greater than 0.5. That gives us our p-value, our parameter, our p parameter. So if it's one of these, Joe Bear, if it says not equal to, greater than, or less than in the claim, then it is in the alternative. If it says equal to, greater than, equal to, less than, equal to, it's in the null. Let me go back through the lesson because probably you didn't watch it. See here, we had the claim was in the null. I know, but how does that make it alternative? I remember from the videos how good it says G. Okay, sure. Claims that at most 10%. So less than or equal to 10%. That's the claim. That's so, and it goes in the null because it's got equality in it. Gotcha. Okay. Anybody else
Wait,
not know how
so
to go ahead?
wait, this is just like a question. It says recording in the top right corner. So is this like recording right now so we can go back and watch it if we need to?
I hope so.
Like this session?
I hope so. Yes. That's what, because I tried to use Zoom and QuickTime at the same time. My computer's just like, no, I don't think so. Dead. But Zoom has an innate recording feature, and I'm not sure how it works, but hopefully it does work like we want it to.
Yeah.
So we may or may not have this saved on YouTube later today. So does everyone understand how to find your hypotheses and determine which one the claim is?
Yes.
If it does work, you should start doing your videos like this, but show. And yes. You never answered my question. What was your question, Jordan? Oh, I did answer your question. You just weren't listening. You don't put in two numbers. You put in alpha. After alpha, you have your mean and standard deviation, but for critical values, it's standard normal distribution, so you don't need it. Just put in alpha. Let me show you again, Jordan. Here's the calculator. Look, inverse norm of alpha with our mean and standard deviation, or inverse norm of alpha. It assumes that it's a standard normal distribution. Right there. So all you need is alpha for your critical values. Oh. So the calculator will assume that it's standard normal unless you specify the mean as something else or the standard deviation is something else. It'll assume it's 0 and 1. Remember that's back in the normal distribution whenever we did everything on the calculator? Same stuff, keep coming back. Okay. We do have one more problem I guess we can go through. It's not very interesting because it's another greater than with the claim and the alternative. But we'll do it anyway, I guess. Indicates that the proportion of defective divide is significantly more than 5%. Okay. A sample of 800 items produced on a new machine showed that 48 of them are defective. The factory will get rid of them if the data indicates that the proportion of defective items is significantly more than 5%. At a significant level of 10%, does factory get rid of the machine or not? Ho and high, H naught, H1, however you want to call them. So this is a 1, Joe Bear, not an I. You could put an A there for alternative, but I use 1. So we know we're talking about a P here. Hi, Trevor. You live, learn, and prosper as well. Significantly more than 5%, so greater than 5%. That's the claim, it's in the alternative. Less than or equal to would be the null. N is 800. 48 are defective, so P hat would be 48 out of 800. And I think my batteries are dying in my AirPods. So alpha is 0.1. P is 0.05. If my AirPods die and you can stop hearing me, let me know. Just my internal mic sucks. 0.95 for Q. Okay, here's what we got. That's the info, that's our hypotheses, there's the claim. Now we just gotta hash out the work. Z is gonna be 48 over 800. That's P hat minus P over P, the square root of P times Q. Over N. And with that, type it into Casio. Mode 1, fraction side of a fraction, 48 over 800 minus 0.05, square root of a fraction, 0.05 times 0.95 over 800. 1.2978. Again, 4 decimal places for the traditional method, because sometimes our critical values have 3 decimal places. So 4 decimal places, what people say. P-value method, you only need 2. But in actuality, we use all the ones we can get in the calculator by storing it to A or B or C or F, whatever. So I'm going to go ahead and
So
calculate
on the
my P.
final,
Yeah.
on the final, we're expected to remember these formulas and like how to set them up based off memory.
You will be given your formula sheet. You'll be able to use this.
Oh, thank God. Okay.
So if we look right here, back top left, test statistics. That's what we're using right here. Next week, we'll be
Okay.
using these 2. We're never going to do anything with chi-square. Yeah, so on the final exam, you will be allowed to use your formula sheet, that exact packet I printed out for you, except we'll have to have a fresh copy. Still no idea what's going on there, if we are going to be, meeting in person or not, if we have to give it online, or I don't know. We'll find out. Hopefully. For our p-value, we're going to do the normal CDF. Again, A will be my lower bound, and my upper bound will be infinity. Leave those alone. P is 0.097. So yeah, it's a pretty big P. But it's not big enough to fail to reject the null. It's still less than alpha. Barely, but it's less than alpha. We reject the null. Okay. TI users should be good to go by now, but just in case, I'll do it one more time. 0.05, 48, 800, and we have a right tail. Let me see. Yes, it's a right tail. 1.2978 for the test statistic, 0.097 for P. So yeah, reject the null. And again, we can get the critical values. For funsies, I'll use the chart. 0.1 is my alpha value, right tail, so I'm not chopping it in half. So I'm looking at 0.1, somewhere in here. 0.107, oh, no, that's 0.01. Okay, this is close. So here we go, I think this is as close I'm gonna get. 0.103. So if I look at that, that's 1.2, yeah, 1.28. And we can, of course, do the inverse norm. We should get 1.28. 1.28. So the critical value is 1.28. Now you will have to know when to use a Z and a T, and if you're looking for an interval or hypothesis test something sign. Can everybody hear me?
Yes.
Okay. Critical value 1.28. That's about here-ish. Shaded over here. Our test statistic is 1.29, so barely over there, but it's in that rejection region. I'll do 3.0. So again, we reject the null. Since we reject the null, claims the alternative, hopefully you know by now what that means, is enough evidence to support the claim that, what was the claim again? I forgot. What am I typing? I have no idea. Oh. Here, you come over here. That the proportion of defective items is significantly more than 5%. To fail to reject the null would mean that we're not. Okay. So if P is greater than alpha, we fail to reject the null. If our test statistic is not in the critical region, we fail to reject the null. So if it was out here, we fail to reject the null. If this is greater than alpha, we fail to reject the null. So that means they're getting rid of that machine. It's a close call, but they gotta get rid of it. Get a new one. All right. Any questions on that one? No? Okay. Nope. You got a question? No, we have a nope. Any questions in general? So make sure you know this right here. You got to know when to say what. How are you today? Not so good. My Minecraft villagers keep escaping their breeding chamber. So if the claim is in the null, then these are our two options. If the claim is in the alternative, these are our two options. Determine if we reject the null or fail to reject the null. And we're done. That's it. We write that conclusion. So here's some different examples of where the claim was not in the alternative somewhere, like this one. It says, test the claim that with scanners, 1% of sales are overcharges. That's equality. So that would make the claim in the null right there. So again, p-value method for two-tail, don't forget to double it after you calculate the area to the right or left, depending on where it's at. If you forget how to find the p-value and you're not using a PI, this flow chart is on your formula sheet. It tells you exactly how to find the p-value. Remember, to find the area under curve, we use a normal CDF. So depending on if it's a left tail, right tail, or two-tail, you do different things. I believe that's about it. If no one else has questions. Okay, hopefully this will be, oh, go ahead. Or not. Hopefully this will be saved as a video somewhere and I'll be able to post it to YouTube. If not, well, at least you got to review the homework. All right, then I'm gonna stop this. And I think we're all good to go. Stop recording.